What's up, guys? This semester we've got an English elective, a sci-fi and fantasy, and we've got a computer science class, and I think these two can go together sometimes. Starting with this small example, let me show you what I'm talking about. In sci-fi and fantasy, I'm going to give them this story, The 9 Billion Names of God, published in 1954 by Arthur C. Clarke. And I won't tell you what happens at the end, but I'll tell you what happens at the beginning. These American computer scientists are approached by Tibetan monks who say, "We need some help with our project we've already been working on for centuries, but we think you might be able to speed it up. Our purpose is to list all the possible names of God. We think we've got this special celestial alphabet, and our job is to go through all the permutations that you can combine these characters." And the guys say, okay, we can modify our giant 1950s computer to do that, and maybe we can help you finish the job in hundreds of hours instead of hundreds of years. And when I saw that, I thought, what if we try something similar? What if we try to do a bunch of permutations of an alphabet? So we got permutations, we're going to time it, and I made a little function here. And if it's only a couple letters, it's not that bad at all. But you'll see that once we add to the length, it starts to take off pretty soon. Let's say we've got 7 letters. Well, it's taking more than a second now to go through all the possibilities. That was about 7 seconds. And let's say we have more. Well, it's going to go for a while. You might think of this as let's say you had a chess program. Look at that, just keep going. Let's say you had a chess program and you told it to just look at every move and pick one. And that works fine for the first move, because you can move a pawn or move a knight, and there's like, what, 20 possibilities? I don't know. But when you get to the third move, now we've got hundreds, and when you get to the 10th move, well, now there are too many to ever look at. And this is something we find when you make an algorithm. It might work just okay with small amounts, but then it might sort of explode once you get to larger data sets you're working with. Now, my question for the computer science class today is, how much does it explode? How much does it build up? Let's say we're going from 8 to 9 letters, okay? Trying to find all the permutations of 8 and all the permutations of 9. How much does that increase? Now, to find that out, you can use a bunch of different methods. You could brute force, just add it in the code and tell, oh, that took 84 seconds. You could say, okay, I'm going to add a line that's going to count. That's going to say, every time I do one, I'm going to add it up. And at the end, it'll tell you, oh, there were 3 million of these, or whatever. Or, if you've done permutations in math class, you might know a formula for that. Or, if you just have good logic mind, you might be able to make a good guess of when we go from 8 to 9, how much does it increase? Or we go from 9 to 10, how much would increase there? But I'll make a post on Classroom and I'll have you guys reply with your ideas. My question for the sci-fi and fantasy class is, after you read this story, which isn't that long, it's a couple pages, what genre would you classify it as? Is it a sci-fi story because it's got a computer in it? Is it a fantasy story because it's got guys in robes trying to say a magic word to summon a god? Is it a horror story because if the ending is bad, it might be kind of scary? Is it a sort of fable, allegory, morality tale? And none of these are right or wrong on their own, but it's all about how you explain it and give some evidence and say what you mean and why. So think about that, and I'm going to post this in both classes today.